Hey everybody, this is Professor Ross, and in this video we'll be talking about factors that affect the width of confidence intervals. So let's take a look at a few notes here. Factors that affect the width of confidence intervals. And we've got a key learning objective. We really have two when we were talking about confidence intervals, but this one especially, this video especially will focus on being able to assess the role of variability or error when estimating a parameter. The width of the confidence interval helps us understand how closely we can estimate the parameter. And so thinking about how variability is going to affect that is going to be a key idea here. We'll think about this example throughout the video, the Affordable Care Act. Recall that in 2013, there was a Gallup poll that reported that 69% of the 1,034 sampled adults reported that the ACA had no effect on their family. And so we could estimate for the entire U.S. population from this sample of U.S. adults that the 95% confidence interval is 0.6618 up to 0.7182. Interpret this confidence interval. I encourage you to pause the video for a moment and see if you can interpret that confidence interval. Here's a great way to interpret this confidence interval. I think of these as percent. So I'm just going to round them to 66% up to, let's round it to 72%. So we feel 95% confident that the true proportion of all US adults whose families were not affected by the ACA in 2013 is between 66 and 72%. So, this is really the heart of statistical inference. We took the results from a sample of just 1,000 adults, and we knew what that result was for our sample, 69%. And then we extend that and make a conclusion about the entire US population, which is pretty impressive. And but we can't be as accurate. We have some error in here, some variability, and that makes our confidence interval range between 66 and 72%. Now, questions we're going to get into are what might make this wider or narrower? And one key thing to keep in mind as we get into these is what do we want? Would we rather have a wider confidence interval or a narrower confidence interval? And the answer is we always want this thing to be narrower, right? It's helping us hone in on what's going on out in the population. And so we'd always love that thing to be honed in a little tighter, narrower on what we're trying to find out about what's going on in the population. So here's a concept we've run into before. I encourage you to pause the video and see if you can review this idea for yourself. The higher level of confidence means that our confidence interval is going to end up being wider, and a lower level of confidence means our confidence interval is going to be narrower. So this was the idea of a trade-off. If we want to increase our confidence, we have to pay for that by having a wider confidence interval. Or vice versa, if we're willing to have a lower level of confidence, a bigger chance of being wrong, then we can obtain a narrower confidence interval. Let's take a look at how this works. We're going to compare the 99% and the 90% confidence intervals to what we saw for the 95 and see how that works. I have gone ahead and pulled up our applets and put in our information here, our sample size and our p hat, our proportion from our sample. Then I checked confidence interval, and here's the 95 that we just saw. Now, what happens if I change this to a higher level of confidence? When I hit calculate CI, we're going to see that both the low number is lower and the high number is higher. We'll have a wider interval. Let's check it out. This has gone down from 66 down to 65. This has gone from under 72 to a little bit over 72. So it's a little bit wider, right? And there's that trade off. We're more confident. There's only a 1% chance that we're wrong about this, but we have a little wider interval. Let's try the other way. I'm going to go back to 95. And so here's our 66 and our just below 72. Let's drop our confidence level. We'll go to a 90%. Now we have a 10% chance of error. And let's see what happens. We should be able to hone in a little bit tighter. The low end should move up a little bit. The high end should move down. Let's take a look. And we get a little bit of nudge up here, just a little higher. And this one here also just goes down a little bit. So we get that trade-off effect happening. So that is one factor that affects the width of confidence intervals is your confidence level. Most people stick with a 95 to get that nice balance between those two, but there are good reasons to go with the others from time to time. Another key factor that affects width of confidence levels is the sample size. The main idea, larger samples give narrower confidence intervals and smaller margin of error. And this is one of the main reasons why statisticians and researchers like to put effort into getting the largest sample as they can, because it helps them hone in and narrow that confidence interval the way we'd like to. Why does this work? We can see mathematically why it works. What happens is our sample size reduces variability in the null distribution. That nice bell-shaped curve, the bigger the sample, the skinnier that thing gets. And the skinnier we can get it, the tighter we can hone in on what's going on. Taking a look at the variability, the standard deviation in the null distribution when we have proportions or standard error if we're estimating it. Where is sample size? Here it is in the denominator. So think this through. If you have a bigger n, what happens to your fraction? A larger denominator leads to the overall fraction being smaller. Just think that through. If you had a fraction like a half compared to a third, compared to a fourth, compared to a fifth, which one is the smallest fraction? 1/5, and it has the biggest denominator. So what happens if we get a bigger sample size? N gets bigger, and well, that's a terrible looking arrow. Sorry, n gets bigger, and our fraction gets smaller, and this overall value gets smaller. Our spread, our standard error in the null distribution gets smaller, hone in tighter. That leads to confidence interval being narrower, and of course, margin of error, each half of the confidence interval is smaller. We have the same kind of thing with the means. Here's the n in the bottom of the fraction. So the bigger that n is, the smaller the spread. So for both categorical and quantitative variables, it works the same way. Both of those are under square roots, and so we square root whatever the sample size is. So for example, in order to double double the effect, yes, cut our margin of error in half, we'd have to quadruple our sample size. So it's not really a straight up relationship. We have to do a lot more sample gathering in order to get the kinds of effects in our margin of error and in our confidence interval. But overall, it's worth trying to pursue as large a sample as possible in order to reduce that confidence interval width. Here, with back to our example, if we had a sample size of about 1,000, we could see our confidence interval here. What happens if we quadruple it? What's going to happen is our margin of error is going to get cut in half. And so the confidence interval will get cut in half. Let's try it out on the applet. We'll change our sample size to 4,136. Let me pull the applet back up here and recall our confidence interval 66 to just under 72. If I change this to 4,000, what was it? I forgot. 4,136. Calculate. We can see, oh, whoops, and I need that same p hat of 69%. There we go. we can see that our margin of error has gotten smaller and our confidence interval has gotten narrower. This went up from 66 up to 67 and a half. This went down from almost 72 down to just over 70. So, general idea, bigger sample size is going to get you a smaller, narrower confidence interval, smaller margin of error. All right, so we've got the confidence level itself affecting us, the sample size affecting us, and then when we're looking at a quantitative variable, means, then our variability in the sample will also have an effect. This is not really anything the researcher has control over. It's just a feature of how spread out the results in the sample are. Main idea, the more variability in the sample, the wider the confidence interval and the larger the margin of error. Um, this should make some conceptual sense to us. So the more things tend to be spread out all over in our sample of data, the harder it is going to be to nail down exactly what's going on in the population, where our mean for our population mu is. Thinking about the math again in the formula, the variability in the null distribution is estimated by this. If the numerator of our denominator, S, the standard deviation of the sample, is bigger, the overall value is bigger. And so if the spread in our null distribution is bigger, then our confidence interval is bigger. All right, so that's just for when we're talking about means. For proportions, the where the sample proportion ends up actually can affect the width of the confidence interval. The idea is that the confidence intervals are wider and the margin of error is larger when our sample proportion p hat is closer to 0.05. So our variability for the null distribution is estimated, the standard error here, with this formula. And the numerator of this denominator is this expression here, p hat times 1 minus p hat. And that value, p hat times 1 minus p hat, is at its largest when p hat is 0.5. So we could play around and try out a bunch of different p hats between 0 and 1.0, and we'd find that it's maximized when p hat is 0.5. So what's the idea here? If you are sampling something and you have proportions, if your sample proportion turns out to be close to 0 or close to 100%, you're going to end up with narrower confidence intervals. If your sample proportion is closer to middle 50-50, you're going to have a wider confidence interval. So those are the main ideas we have for factors that affect the width of confidence intervals.